Good morning, everyone. Thanks for being here this morning. Thanks for joining this talk. I've heard traffic jams are a thing in London, and there was also a slight traffic jam getting in the room, so that's why we started a few minutes late. I hope you don't mind. My name is Maarten, as you might have noticed, and in the following hour or so, we're going to discuss some microservice problems that you can encounter when you are doing a microservice architecture. And how Kong or any other API gateway product might help you with those problems. So the talk is roughly outlined like this. We'll discuss API management. We'll discuss what an API gateway is. And once we've done that, we'll see a few demos to illustrate the problem. We'll dive into Kong, one API gateway solution. We'll see how that works, what you can do with it. Discuss some of the internals. Why you might choose for Kong, or you might choose to do something else than Kong. And of course, there's a wrap-up. If you have any questions, just raise your hand, shout out loud, because there's quite a big room, and I might not be able to hear you, and I'll try to repeat the question if I remind that. So, without further ado, what is API management? If you want to know what API management is, well, the first thing I usually do is I go to Wikipedia. So Wikipedia says API management is, and I've highlighted a few words there for you, it's the process of creating and publishing web APIs, enforcing usage policies, very important, controlling access, also very important, nurturing community, well, that's all not important because it's not highlighted. So what is API management about? Publishing, enforcing policies, controlling access, basically. That's the main things I want you to take from this one. Now, it's good to know that API management exists on multiple levels. You can do API management on your enterprise level, which means you're publishing and protecting and securing APIs for the whole of your enterprise. And depending on the company you work with, this might be rather large, of course. There's also API management one level lower, on the domain level. So a specific part of your enterprise is publishing APIs and wants people to have access to that. And on the lowest level, we see API management at solution level. So that's basically one system or a group of small systems. Did somebody say microservices, for example, where you want to have fine-grained control on the APIs that you are publishing and who is able to who's allowed to access them under what conditions. So API management, in this talk, will mainly be focusing on the latter level, so that's solution level. We'll see how API management can solve certain problems for you when you are having one solution, whether or not it consists of multiple independently deployed components or not. And to illustrate the first problem, I have a small demo for you. I myself like craft beer, so I figured it has to do something with beer. It's a bit early for beer though, but well, please bear with me. I've got a small demo application which is built with Java EE 8, and it has two modules. One service handles breweries, so the companies that make the lovely beer for you, and the other one handles the beers themselves. Let's see. Here we have a small beer API. This is just a standard JAX-RS resource. And as you can see, it invokes a service to find beers given a certain brewery ID. And on the other hand, here we have the option to find information about a specific beer. And if the identifier of the beer does not exist, we'll just throw an exception like, well, it doesn't exist. This is just standard Java EE stuff with JAX-RS. There's actually nothing special there. But what if we wanted to deploy our solution? We have the beer resource. We also have a brewery resource, which looks pretty familiar. It returns information about breweries. If we are going to deploy this, we could use Docker Compose, for example. I'll just fire it up. It creates a beer API, it creates a brewery API. Now, this is all fine and good, but if we would like to invoke it, what do we see? The first API is the brewery API. It lives on port 10,002. The second one lives on port 10,001. This isn't pretty, right? This is a very common thing. It's called an addressing problem. We have two components, but they can't listen on the same port. And if I'm doing microservices, I'm having independently deployed components, so I'm not deploying two WAR files in one container. No, I have one container with one WAR file in it. So although it works, it is not pretty. And what also is quite unpleasant is the fact that I want to have some kind of security on my, my enterprise solution. It's an enterprise solution after all. So I require my clients to give an API key. Well, the key itself is not very important at the moment. Let's just see it says this value. But how do I enforce that? Well, I have an interface that describes how to authenticate a client. Given a request, it might give me a principal, which is the Java EE construct for, well, an authenticated entity. And given that entity and the request, there's another method that tells me the groups it is a member of. And in this case, I'm seeing an implementation of that interface, which has the key there, hard-coded. Okay, well, you could retrieve it from a database, obviously, but still. And I've a tiny piece of code which will read some magic header from the request, and it will verify if that key is indeed allowed to access the resource. And if there is a principal, I'm always assigning it the group API client, which then translates back to, for example, the resource which requires the client to have that role. This is all fine and good, but the thing is that now every component in my microservice solution needs to have this module deployed. It needs to have this class deployed. And if there's a bug in it, I will have to redeploy all of my modules in my microservice. That's also not very pretty. So what do we see? We have a front end which lives up there. I did not show you that. My front end was just an HTTP client, but it could well be a single-page JavaScript application or a web application or whatsoever. And the front end needs to know the different addresses for the different resources, the different Java EE applications. It needs to know that, for example, if you retrieve a brewery, you need to go to one port, and if you need to retrieve a beer, you need to go to another port. Well, that's plain ugly. And critical components like security measures are deployed in each and every container. Well, that's definitely not what I would like to see if I'm building a microservice solution at scale. So, now enter the API gateway. What is an API gateway? Well, just as we did with API management, we could ask Wikipedia, which is rather a disappointment to me. Wikipedia doesn't know. That's always a bad sign. Luckily, there's other sources that can tell us. Disclaimer, these are vendors of API gateways, so they might have a little bias there. Amazon, for example, offers an API gateway within AWS, which is fully managed, blah, blah, blah. Well, it makes it easy to publish and secure APIs at scale. Well, okay. Once again, bear in mind, this is vendor content, so they have a certain desire to sell you something. But okay, an API gateway can do publishing and securing APIs. Azure also has an API gateway product, and they all have similar words. They say Azure API management is a solution to publish APIs, to secure and protect them, and to get insight from usage and health even. Well, that sounds amazing. So there are some vendors selling you API gateways or API management solutions. And that fits pretty well in the definition of what we think API management should allow us to do. That's good. Now, going back one step to the microservice architecture, what we usually see is that they don't have like two services, as we just saw, which is a very simple and contrived example, of course. But that there's many components of them. They all have different addresses. They have they might even have different implementation languages. I've just used Java EE, but maybe one of those components is written in Python or in Go or in, well, whatever language. So even if I would allow myself to have this security logic, for example, duplicated all over these modules, I might probably also be re-implementing it a lot of times. Because this platform that I'm building this specific microservice with is written in Rust. And I don't have the security components written in Rust yet. So well, let's first start to re-implement that in yet another language. That's typically not the kind of value we want to deliver. We actually, if we are building microservices, wouldn't it be nice if we could just say, well, we are sure that as soon as you enter the solution, as soon as a request comes in, we can be sure that it has been authenticated already and that it has been authorized already. So that we will be able to say the request that comes in is allowed to at least invoke this service. And maybe within the service there's fine-grained control like, hey, you're a customer, you're requesting to see an order. Was the order actually created by you? That's the type of things that you still need to check in your application, of course. But for the majority, it would be pretty cool if we could just trust on requests coming in and being secured. Now, the problem that we just saw with the different addresses is pretty simple to solve. I think many of you might have said, well, just throw Nginx in front of it and you're all done, right? Who did not think about, well, just throw Nginx in front of it? And okay, let's just reverse the question. Who was like, Nginx will solve this for you? Okay, I'm glad to see quite a couple of hands because that is a very good idea indeed. It's just a very basic solution to tackle this. And of course, there's more solutions. I mean, Nginx would do that for you. HTTP would do that for you. Zool from Netflix would do that for you. And typically, a reverse proxy has a few capabilities that are pretty useful already. They can do routing. So I have one public address, and the reverse proxy will know, okay, if the request comes into this context, I'll just redirect it there. And for another address, I'll just redirect it there. What it typically also does for you is it will offload TLS SSL connections. So on the outside, you have published your APIs. The address starts with HTTPS, which is excellent. On the inside, you don't want to have the private key that corresponds to the certificate in each and every service. You might create a private subnet, deploy all your services there, and have firewall rules that protect that from the outside world, and just have the reverse proxy offload TLS for you. And it can often do load balancing for you. So if you have one service that is a bit heavy, you'll just deploy 5 copies of them, and you'll ask the reverse proxy to do a round-robin load balancing. First call goes to the first instance, second call goes to the second instance, so on and so forth. This is all powerful, but we can do more. To me, that's what the difference is between a reverse proxy, as we know it for years already, and an API gateway. Because an API gateway can do many, many more things, and I've listed just a few of them. As I said, it can authenticate and authorize clients. It can enforce rate limiting. So it can say to a client, well, you're sending too many requests. Please calm down. It can do access logging. It can do a metering, like exactly counting how many invocations you've had. It can keep metrics like response times, error codes, etc. It can do compression, gzip compression, for example. It can do IP blacklisting, whitelisting, very powerful if you want to restrict access to your solution to just a few clients that you know in advance. It might even do caching. And if you go one step further, some people even add things like aggregations and transformations. So they'll say, okay, you invoke this endpoint. To give you an answer, I'll invoke this one and I'll invoke that one. I'll combine the results, I'll transform it a little bit and send it back to you. Very powerful also. To me, that is one step further. That would be a backend for frontend, for example. Because it does more than just than just intercepting. It will also do transformations, and it will modify the response. So there's quite a few gradations there. You have a reverse proxy, very basic. You have an API gateway, which does quite a lot of things for you already, and you can go even further. But I would call that a backend for frontend. Now, we can see how that works in practice. I have a second demo for you there. I'm first stopping the first demo that I did, and I'm going to start the second demo. To do that, I first need a database. Which is now starting. And of course, if you're doing a demo, it always starts a bit slower than the last time you did it. Yep, there it is. I'm preparing the database to have the right data in it. And now I'm starting a few components. What I've just deployed is a very basic Kong setup. And in a few minutes, we'll see what that consists of. But just for now, let's assume that we have a Kong instance. I'm going to configure the Kong instance and let you see what the result is when I want to invoke the solution. So, as I said, first there's configuring the Kong instance. And what we do here is we define the services that we need. We define the upstream implementation of the service, which is abstracted in a target. So we need to have a target definition as well. We define the routes under which it is published. And once that's done, we can actually invoke one of our microservices, the Beers API in this example. And what we see is that if we don't supply the API key header, well, that was a bit quick, I think, that we got a 401. So my implementation is still doing security itself. As you can see, the server says it's IBM Web for Liberty, so it's still the microservice itself being responsible for doing security checks. We're not there yet, we're just getting started. But now, if I add the API key, it will tell me 200, OK, and I've just stripped out the response body because that's just a blob of JSON, which is not relevant at this moment. So we're doing the same thing now for the other module. The brewery API also needs a service, an upstream definition, targets to match that, routes where it is published, and then if we invoke it the same way, without an API key, it will be unauthorized. With an API key, we'll get HTTP status 200, and we're good to go. So what did we just see? This time, we have a front end, which is just an HTTP client again, which talks to Kong. And once again, we'll dive into Kong in a few minutes. Kong will know where the different microservices live, what their addresses are, and how they are to be published. And it will redirect calls to either the Beer API or the Brewery API. And both of them still require the request to have an API key. So the secret, the API key itself, is still present somehow in both modules, which is typically not what you would like to have, but that's how it currently is. And in the further demo, we will see how to also fix that. I said there's a lot of configuration going on. If you want to use Kong, there's a few concepts that you need to know of. These are services, upstreams, routes, and targets. Here at the right, we see targets. A target is just a running instance of your microservice. So that's where the actual implementation lives. And you can see I have 2 copies of the Brewery API, and I have 1 copy of the Beer API. And I can even assign a different weight to both of them. So I can say, well, this one is on a heavier service or server, or this one is a preferred implementation, and this is for A/B testing, so I don't want all calls to go there. Then we have an upstream, which is just the abstraction of having multiple targets. Then we have the service that's sitting down there, and the service is like, well, there is something like a beer API or a brewery API, which you can invoke. And at the left, we see the routes under which that service is being published. And routes contain of a path and a method. And you can describe even more parameters to match or not match a request. But at the very basic, it's that. It's just paths and a method. So what it says is, if there's a GET request coming in to /API/brewery/whatever, send it to the brewery upstream, which will, send it to the brewery service, which will route it to the brewery upstream, which will then do a load balanced invocation over 2 targets, where one target gets twice as much traffic as the other one. Now, let's dive into Kong. Kong, as I said, is an API gateway product. It is being developed by a company which is also named Kong, just to make things more clear, I think. And it's actually based on Nginx. It's built upon Nginx. Nginx is as we already know, is a very lightweight web server, and Kong just adds upon that. It stores all of the configuration, like the services, the upstreams, the targets, etc., in a database, which can be either a PostgreSQL database, as I'm using in my demos, or it can be a Cassandra database. But with version 1.1 that came out, I think a month ago, you don't need a database anymore. You can actually run it in a database-less mode. That will also drop some of the capabilities that it has, but it solves or it resolves one dependency. The database is not necessary anymore. Kong exposes 2 interfaces for you. One of them is the public interface. That's the one that is exposed to your clients, and your clients get the address and get to invoke your APIs. And there's also a private interface. The private interface is for you as an operator, as a DevOps team, or as a systems administrator, doesn't really matter. And in the administration interface, or the private interface, you'll have REST methods to configure Kong. So this is kind of a API inception. You are using APIs to administer APIs. And the very first time you're doing that, it feels a bit weird, but well, you get used to it pretty quick, actually. You can deploy Kong in multiple ways. You can just run it standalone. First of all, as I just did in my machine, I'm firing up a Docker container, starts Kong. You can run it in clustered mode, but this always requires a database, because the database is the shared state for all instances in the cluster. And you can even run it in your Kubernetes environment as an ingress controller. So you will attach labels to your pods, telling the ingress controller, hey, send this configuration to Kong, so Kong knows where to route calls. And what is also very powerful is that you are completely free where you want to run it. Unlike API management solutions from cloud vendors, which only run in their cloud, of course, Kong can be run anywhere. It can be run on your machine, it can be run on a data center inside your company, in the cloud. It's completely up to you where you want to run it. And there's typically 4 use cases how Kong is employed. The first one is a very trivial one, actually, where it's just a reverse proxy++. So there's one system, and Kong is sitting in front of it and intercepting all traffic. This is the very simple use case. The second one is where you deploy a bunch of services inside a private subnet, and you protect them by putting a Kong instance in front of it, or multiple Kong instances in front of it. And Kong is then responsible for routing all the requests. As I said, you can deploy it as an ingress controller on your Kubernetes cluster, and it will actually have tiny sidecars with each component, which are then controlled from the control plane. And last but not least, you can even run Kong to split traffic over multiple clouds, for example, or multiple data centers. So it can be a load balancer over a whole variety of deployments, some on-premise, some in a cloud, some in another cloud. And you can tell Kong, like, okay, well, some of the traffic needs to go there, some of the traffic needs to go there. And it's completely transparent to the consumer of the API. He doesn't even know where the call is being routed. But what makes Kong really powerful is plugins. Because what we've just seen, well, one might say this is still possible without Kong. I can deploy Nginx, I can ask for a request header being present, or maybe I use HTTPD for that. But the real power of Kong is its plugin system. Plugins come in a few flavors. Many of the plugins are open source. So they are developed by Kong and then made open source, and they are free to use. Some of the plugins have an enterprise flavor as well. For example, there's an OpenID Connect plugin, which is enterprise only, and there's an LDAP plugin, which is open source, but the enterprise version is way more powerful. And you need to have an enterprise subscription for Kong, enabled to use those. And finally, there's even third-party companies that are building, shipping plugins. For example, Nokia has an OpenID Connect plugin, which you can just get from GitHub and deploy in your Kong instance. Those plugins are implemented in Lua. Lua is Portuguese for a moon, which it's a scripting language that's very popular in game development because it's lightweight and it's very fast. And it's also the main language to extend Nginx. You can run Lua script directly in Nginx, and that's basically what Kong does too. So Kong itself is written in Lua, runs directly in Nginx, and your plugins are also written in Lua, deployed into Kong into Nginx. The general pattern, if you want to use a plugin, is that you invoke your private interface. Typically lives on port 8001, but you can choose that, of course. And for example, here I want to enable a plugin on a service. So I'm specifying the service name, and I'm invoking the plugins endpoint, and I'm giving two parameters, the name of the plugin that I want to enable, and some configuration parameters. Those are optional. But each plugin clearly documents the parameters that it accepts and what these parameters do. So, for example, if I would like to employ rate limiting on the beer API, I could say, okay, give me the beer API service, invoke the plugins endpoint. I want to enable the rate limiting plugin, and I want to limit it to, what does it say, six invocations per second, or 10 per hour, whatever. That's up to you, of course. And using CURL, for example, but could be any HTTP client, you can enable a plugin. Now, the cool thing is that plugins can be defined at many levels. You can enable a plugin on a service, on a route, on a target, on an upstream. But you can also combine multiple plugins on the same route, or on the same target, or on the same service. So, for example, you could say, okay, I want metering, I want a rate limiting, and I want a security plugin to enforce certain security checks. So let's dive into the security plugins, because that's a whole set of plugins which are very powerful. Authentication is done using plugins as well, and the basic idea of an authentication plugin in Kong is that it will find some credentials in the request, in the incoming HTTP request, and map that to a consumer. The consumer is a separate concept in Kong, which is the abstraction of, well, someone who you would like to grant access to your APIs. And a consumer can have multiple credentials of multiple types. So examples of credentials are just an API key, as we just saw. It can be a username and a password. It can be a certain OAuth scope, which is granted by an external provider. It can be a client certificate, for example, a TLS client certificate. All of these can map to one consumer, can identify one consumer. Now, if that process succeeds, so Kong is able to extract something from the HTTP request that translates to a consumer, it will add two headers to the HTTP request that goes upstream. It's X-consumer username and X-consumer ID. And those two headers tell the upstream service, whatever language it was implemented, doesn't really matter, hey, I have successfully identified an API client for you. The ID is, well, can be anything, and the username is something that you give it. So let's see how that works. If I would like to implement that in my Java EE solution, for example, I could say, okay, my principal, well, it looks at the X-consumer username header. There it finds either a value or no value. And if it's there, I'm creating a principal out of that. And principal, once again, is just the standard Java EE construct for, well, some identified entity. And if I want to know what groups this principal is in, well, I can look at another custom header, the X-consumer groups header. I could split that on the comma value, trim it, and put it in a set. And that way, I would be able to know the groups that Kong assigned my user to. And if I want to run that, I'm first stopping the previous demo, starting the third one. Now what I need to do in able to use this is, at first, I need to create a consumer. So that's just the abstraction of someone who is allowed to invoke my APIs. Next is that I'm assigning this user a key. It's the same key as before. And then I enable the HCL plugin and add this client to a group called API client, as we can see there. So I'm saying the DevOps UK consumer. I'm invoking the HCL plugin on the user, on the consumer. And I'm saying, okay, the group that I want to put this consumer in is API client. Remember, API client was also the role that my Java EE service requires you to have in order to invoke the endpoints. Now, Kong says this is all fine, created. Now I can secure an API. I can say, okay, on my brewery API, for example, I want to enable the key off plugin. And I also want to enable the HCL plugin. So here we see two plugins being configured at the same entity. And I'm saying that the only groups that are allowed to invoke this API are members of the API client group. Same thing for the beer API, enabling key off plugin, enabling the HCL plugin. And now I'm able to invoke the brewery API. If I don't specify an API key, Kong will say, no API key found in request. You have enabled the API key plugin, it was not in the request. So I'm not granting you any access. And what you can see is that the server now is Kong. So it's not, the request is not hitting my Java EE application anymore. It's being blocked by Kong already. Okay, I'll just invoke the API with the API key as I did before. Kong will still say there's no API key found in request. Why is that? Because by default, it expects the header name to be API key in small letters. But you can configure that using one of the configuration parameters for the key off plugin. So, what did we see? Kong will now try to authenticate the consumer, in this case using an API key. And then it will also assign a group to the consumer. In this case, it was API client. And it will then invoke the beer API or the brewery API with the consumer and the groups that it has determined to be applicable there. Okay, this is all fine and good, and as I said, there's a whole bunch of plugins, but you can go even one step further and write your own plugins. There's a plugin development guide and a plugin development kit. The plugin development guide is just documentation, which takes you by the hand to explain you how to do it. And the plugin development kit is like an SDK that you can import in your Lua project, so you have the right stuff to get started. The slide deck will, of course, be published, and those are hyperlinks, so you can easily get there. What does a plugin look like? Well, it requires you to have a very strict directory structure, which looks like this. An important thing here is that you name your plugin, and you have api.lua, DAOs.lua, handler.lua, migrations to configure what the database schema should look like, and schema.lua. And if we are to implement the handler is the thing that gets invoked by Kong to perform your plugin logic. The first thing we need to do is we need to import something from Kong, which is a base plugin, and we extend that. So we'll just define my plugin handler. We give it a priority, which basically says when in a request handling lifecycle the plugin is going to be invoked relative to other plugins. And we can define a version. We need a constructor, which just invokes a super constructor. And we need to define at least one context. In this case, it's the access method. And the access method receives the configuration as a parameter. It can just delegate to super, and it can do custom things. In this case, it will do a very stupid thing. It will just log the fact that it was being invoked. But of course, you can imagine you can do very complex things there. And those request contexts, there are a few of them, and they allow you to intercept various phases within Kong's lifecycle and within Kong's request lifecycle. For example, you can hook into the moment where Kong starts up, when Kong will serve its TLS certificate, when request writing is being done. Until that moment, Kong doesn't know yet which API is going to be invoked or what the consumer is. It's just unknown as of that moment. From then on, you have access to the API definition that you are going to invoke, as well as the identified consumer. And then you can intercept the moment that upstream is being sent the HTTP request, or when upstream sends back its response headers. For each chunk of response data, and be aware of the fact that there can be many of them for large response bodies, you can also intercept that. And finally, when the last byte has been sent to the client, you can also intercept that moment. So depending on what your plugin is going to do, you need to think about which request context am I going to implement. You can be too early or too late, simply put. Now, what can you do with it? I'll just demonstrate. I'll just mention a small case study. We had a situation like this. We had API clients, which would invoke our API with a client certificate, standard X509 certificate. And it would first hit a load balancer. The load balancer would typically do TLS offloading for us. That's how it behaves by default, because behind it is an intrusion prevention system. And intrusion prevention systems, they just inspect each and every TCP packet. And when that is encrypted with TLS, well, it cannot do that much useful stuff because it's all encrypted. So the default in this situation, in this company, was the load balancer will do TLS offloading, and the intrusion prevention system will do its security checks. And then the request would hit Kong. Now the thing is, we actually wanted this client certificate to be able to identify a consumer, because they are granted to a specific identified business party with which we want to do business. And we didn't want them to say, okay, you need a client certificate, and you also need to send an API key, because, well, our infrastructure looks like this. So we wanted to make use of that. Well, we came up with a solution where the load balancer would strip off a few fields from the TLS certificate being offered by the client, like the common name and the SHA-265 hash and some other things. And it would send that information with the request to Kong, and then Kong would be able to use those fields to map them to a consumer. As I said, a consumer can have many credentials, and you can even define your own credentials for a consumer. So what we did is we defined a credential which basically says TLS certificate. And if a TLS certificate has this common name, this SHA-265 hash, and some other stuff, it belongs to the consumer, and we can identify the consumer as such. And once that has been done, we'll just put the standard ex-consumer username and the ex-consumer ID on the request, and we'll know in the upstream implementation that the consumer was identified based on the TLS certificate. So that's just one tiny example of the powerful things that you can do with plugins. Now, why would you use Kong, or why would you not use Kong? Because I'm not here to tell you Kong is the answer to everything. You might already have noticed. It depends on your case, and maybe it's good or maybe it's not. Things that we were looking for when we wanted to have some API management solution. Obviously, we took a look at the costs. How many euros will it cost us if we are going to run this? How good can developers work with it? How's the documentation? Can we easily expand it if it doesn't meet our requirements? How well is it maintained? Is there support available in some sense? Does it actually do what we want it to do, both on a functional and a non-functional way? It's hard to tell, but is it in any sense future-proof? Is there a company backing it, maybe? And how easy would it be to replace it if we don't want it anymore and we want something else? Are we locking us into the product or not? Well, what we observed is that the open source edition of Kong out of the box had quite a good fit on functionals and non-functionals. If we wanted, we could buy support, but it was not required to do so. So that was very interesting for proof of concept, like we're not completely sure if we want to do this, but well, let's get started. It doesn't cost us anything, at least not in euros. There's an active community with people all over the world contributing to Kong. They have frequent releases, and the documentation is pretty good. What we've seen so far, because we're running it in production for about a year by now, is that the REST interface to define your APIs is pretty quick and easy to understand. As soon as you got figured out how to read the documentation, it's pretty easy to change configuration, even in a running instance, without having to restart the whole thing. The configuration using APIs, well, it takes a few moments to get used to the idea, but once you have that, it's easy to understand from a developer's perspective. The thing is, you typically do that in an imperative way. You're invoking this administration, this private interface, using CURL, maybe you script it a little bit, but the imperative scripting, as soon as you start to have a few APIs and a few consumers, it starts to get a bit clunky. And if you want to know, okay, which consumers do we actually have? Well, either you ask Kong, or you read the scripts that provide you the configuration, but the scripts are imperative, so what's the end state? I don't really know. With Kong 1.1, there's tooling available to do that in a declarative way, which is way more powerful in our experience, because we just define, okay, this is what we want to have. We want to have 4 consumers, 3 APIs, those are the paths, those are the services, the upstreams, make it happen for me. That's way more easier than having to do it in an imperative way yourself. Before Kong 1.1, there was already external tooling available like Converge or Config, which would more or less do the same. The first upgrade that we did was from Kong 0.13 to 0.14.1. This was a breeze. We hardly had to do anything. And the second upgrade from 14.1 to 1.1 was a bit harder. Some of the internals changed, so we had to update our plugin as well. The way in which the database structure was provisioned was a little bit different, but still was a pretty easy path. And what we also saw when we did demos to stakeholders inside the company was that they were a bit, disappointed. Because they expected to have nice graphs and pictures, and we just showed them Postman invoke. Or even worse, the first time we did it with CURL, and we really lost them there. The cool thing is there is also external tooling like Konga or Kongdash, which provides you with a nice management dashboard. So it will give you graphs and gauges, and that looks just pretty. And the good thing is that business stakeholders like that. They want graphs, they want to see that everything looks cool and everything works, and well, That's just, you can easily deploy that one as well, and it will just look better for your business stakeholders. This is all I had for today. I haven't seen any hands being raised, but if you have any questions, we have a few minutes left to answer them. I think you were first. Could you please repeat it? Yeah. So how would you prevent Kong from being a single point of failure? As I said, you can run in a clustered environment, so you can have many Kong instances sharing a database with the configuration and also things like state for the rate limiting plugin, for example. And then you could put another load balancer in front of that, like an F5 or something that your cloud provider gives you, so that you can provide, so you can balance the load over the Kong instances. Well, there's two of you. Please fight.
So I understand this as an entry point into your application. But if you have multiple microservices within your ecosystem that they communicate to each other and are usually protected by SSL, would this be useful?
I'm not sure if I understand the question correctly.
Coming in from the outside world.
Yeah. I'm sorry, I failed to understand the question. Maybe you can come up to me afterwards, because there's a bit of a distance and I have trouble hearing you. You're sitting in front, so that should be easier.
Does Kong offer something about documentation also of these API APIs that you have?
Is there some way?
What do you suggest for that?
Yeah. The question is if Kong provides a way to document the APIs that you're publishing, right? Well, there's nothing that is in Kong itself. Kong is about publishing the API, but not information about the API. You might be able to write a plugin for that, I'm not sure. But things like Swagger can really help. And what we actually do is we write Swagger files and publish them, even using Kong, because at the end of the day, Kong is a web server. And we publish the Swagger files plus a Swagger UI, and we give that to our consumers. And that's the documentation they get when they want to invoke the API. Last question, please.
In the beginning, you talked about redeploying the individual microservices if you updated the authentication Java interface. If you're writing Lua plugins and you're redeploying those, do you have to restart Kong?
The question is, do you need to restart Kong if you want to update a plugin? And I think the answer is typically you don't need to restart Kong. But I'm not exactly sure, to be honest. I think what we currently do is force it, well, just to be sure, we restart Kong. We have two instances, and there's a load balancer running in front of it. So we'll just shut down one instance, redeploy with the new plugin, and start it back up, because the other node will take over. I'm not completely sure if that's necessary. It's more of a precaution from our side. Time's up. If you have any more questions, find me around. I'll be the whole day here tomorrow. Thanks for being here. Thanks for your attention, and have a wonderful day.